So for number 12, since it's in vertex form, I can find the vertex, the axis of symmetry, and so many other things right away. So let's start with the vertex, which is take the opposite, do the axis of symmetry. The y-intercept isn't as easy right now. The domain, all real numbers, negative infinity to positive infinity. The range I can get right now. Now, I better take care of whether it opens up or down. This negative means it opens down. So since it opens down, it's going to be less than or equal to the y value of the vertex, which is 12. Which means if it's going down, it's starting with negative infinity and going to 12. Okay. I can actually do the intervals as well because the intervals are tied in with the vertex. So I'm going to draw it. Negative 2, 12. This is negative infinity. This is positive infinity. Focus on the x values. From here to here, it's increasing. Negative infinity to negative 2. And then it's decreasing from, parentheses, negative 2 to positive infinity. Okay? I can do the end behavior. As x approaches negative infinity, f of x approaches. As x approaches positive infinity, f of x approaches. And since it's going down, the answer is negative infinity. Okay. I think I'll approach the x-intercepts and y-intercepts now, and I do want to point out that the vertex form will be worth less points than standard form because you need to do more work to find the vertex in standard form. All right, let's do the y-intercept first. I feel like that one's a little bit easier. So to get the y-intercept, I'm going to plug in, let me move that over, 0 in for for x, excuse me. So I'm going to plug in 0. Make sure you deal with the littles before the big. 0 plus 2 is 2, squared is 4, times negative 3 is negative 12, plus 12 is 0. With that being said, that means the y-intercept is 0, 0. Now, if the y-intercept is 0, 0, one of my x values should be 0, 0, okay? If I'm not sure, I could graph it. So maybe at this point I will graph it just to double triple, Control G, negative 3, parentheses, x plus 2, squared, minus 12. Okay, let's try it again. I'm not sure what happened. All right, maybe there's something wrong with my calculator, so we'll worry about that later. Okay. So let me continue. So now to get the x-intercept, I'm going to plug 0 in for y. Negative 3, x plus 2 squared plus 12. Subtract 12. Oops. Careful, don't do what I did. I said subtract 12 and then I put it. Divide by negative 3. Square root, plus or minus 2 equals x plus 2 minus 2. So my options are negative 2 plus 2 and negative 2 minus 2. Negative 2 plus 2 is 0, and negative 2 minus 2 is negative 4. So I was right, because the y-intercept is 0, 0, the x-intercept is 0, 0. With that being said, I want to be clear about the x-intercepts. If I go back to standard form, it wasn't applicable because this was imaginary. Okay, or actually it wasn't imaginary. So I guess we're good on that. So with that being said, I want to remind you, for the x-intercepts, you need to write them as points now. So 0, 0, and negative 4, comma 0. So I'm going to plot this now. 0, 0, 1, 2, 3, 4, negative 4, 0. And then that covers the x-intercept. It also covers the y-intercept. The vertex is negative 2, 12. Okay. That looks like that's right there. I'm going to graph it. And I'm going to show the axis of symmetry. Okay. All right, number 13. They want it in vertex form. If they want it in vertex form, I have to find the vertex. The formula is negative b over 2a. My a is 2, my b is negative 8, and my c is 6. So negative b over 2 times a negative and a negative, positive 8 over 4. My x value is 2. So now I'm going to take the 2 and I'm going to plug that in for my x. Two squared is 4, times 2 is 8. 8 minus 16 is negative 8, plus 6 is negative 2. Now that I have the vertex, I need to write this in function form. It's the exact same function, so don't put g of x. It is the exact same function. Now I need to reiterate that if there is a number in front, you have to acknowledge that. Okay? Do the opposite, because that's the x, and the y is a straight shooter. Now to check it, because my graph isn't working, let's go to calculate. What I can do is take a number 2, and I store it for x. And then I'm going to write my original function, 2x squared minus 8x plus 6, and I'm going to set it equal to my new function. So 2 parentheses x minus 2 squared, and then minus 2. And it should say it's true, and that's how I know that I did it right. Remember I said don't do 14 or 15. Now, for number 16, you need to solve this in 2 different ways. I'm going to solve it in 3 ways, just so that you can see all of them. Actually, I can't do it in 3 ways. So I try to factor, but I can't factor, so my only option to do is quadratic formula and complete the square. So let me do quadratic formula. My a is 1, my b is negative 6, my c is negative 3. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. You know I take care of that first. So the square root of 36, a negative and a negative make a positive. 4 times 1 times 3 is 12. Square root of 48, tree, and I get 4 rad 3. Now that I have the 4 rad 3, I'm going to rewrite it as negative, positive 6, plus or minus 4 rad 3 over 2, divide by 2, which is 3, 2, 1. So it ends up being 3 plus or minus 2 rad 3. I split it, get my answer in my calculator. 3 plus 2 rad 3, 3 plus 2 rad 3, 6.46. And then 3 minus 2 rad 3, which is negative 0.46. Now, normally I would say graph it, but if you solve by completing the square and you get the exact same answer, you know you probably did it right. So let's solve by completing the square now. I'm going to move that negative 3 over, so it's x squared minus 6x equals 3. Do your little box. I'll do that down here. X squared half xx, negative 3. So I'm going to add that 9 plus 9 plus 9. That's 12. Do my box. X minus 3 squared, square root. X minus 3 equals plus or minus tree, and you get 2 rad 3. X equals 3 plus or minus 2 rad 3. And as long as you show me, give one of them as a decimal, show me that these two are equal, I'm a happy person.